Well, enough with the introductions. Let's get right into evaluating things. Come on, let's put all that we learned to work. Let's evaluate each of the following. Well, remembering what I taught you, let that equal to v. There's the base, raise it to the power. 4 to the power of v has to equal to 64. And the whole idea behind this now here, sports fans, is convert that 64 into that base. Because if you convert it into that base, we cancel the bases, we know what v equals to. It's that simple. So in other words, 64 has to be some base of 4 to the power of something. Well, if you can't figure that out, folks, just go out and use your calculator, okay? Figure out what power of 4 gives us 64. So I got my calculator here, and let's start playing around. 4 to the power of, well, it's definitely not squared, because we know that that's 16, but let's just go up. Maybe we'll jump. Let's try 4 to the 4. Well, that's way too much. How about 4 to the 3? Oh, there's 64. Of course. 4 cubed is 64. Now, remember, this was 4 to the power of v. Look, like bases cancel, guess what? V equals to 3. That simple. V equals to 3. Your answer here for this question is 3. That's no problem. Well, then, how about if we have something that has a 2 up front? So what? Just put a bracket around this. Do what's inside the bracket first. So if you look at this, this is now log 8, right, of 512. Remember, let that equal to v. 8 to the power of v equals to 512. So that means this 512 has to be some sort of version of 8. 8 to the power of something. Okay, let's figure out what that is. Again, lots of guessing and checking. Go into your calculator and go 8 to the power of, now we know squared is 64. So let's try 3. I don't know if that works. 512, look at that. It worked right off the bat. Okay, so we know that this becomes 8v equals to 8 to the power of 3. The 8's cancel, v equals to 3. So this means that this whole thing is now just plain old 3. But we have a 2 in front. That's simple enough. 2 times 3, your answer, 6. That's how it's evaluated. Nice! I'm getting the hang of this now. Okay, so let's keep on going. I'm feeling really confident here until, of course, we run into a fraction. As soon as you write down fraction, everybody goes, relax. Watch. 2 to the power of e, same thing as we always do, equals to 1 over 32. Now, think about what you learned in Math 10C. When you get 1 over something, can you not write this as 2v equals 32 to the negative 1? That's what negative exponents tell you. Now, what you have to figure out is find 32 in some form of 2. So let's go to our calculators again. 2 to the power of something gives us 32. Let's start throwing some numbers out there. Let's try 3. No, I know that one. That's 2 to the 8. Okay, but how about 4? Well, didn't that be 16? How about 5 then? Okay, 2 to the power of 5. Oh, there's the 32. Perfect. So we know that this 2v equals to 2 to the power of, what was it again? It was 5. Okay, 2 to the power of 5. But look, didn't you have a negative 1 out there already? So guess what? That's negative 1. Well, across the bracket, you just multiply. So this is 2v equals 2 to the negative 5. Cancel out the 2's. V equals to negative 5. Oh my goodness, which makes sense. Because you remember the last podcast, being that this was a fraction, you knew right away that you had to have a negative answer. Right? It's that idea of flipping. That flip right here changes the answer to a negative. All right then, what about something as ugly as that one? Look at D. Ugh. Simple, simple, simple. I'm going to write it over here and then I'll just erase it later. Do you remember radicals? Do you remember this? Do you remember this? Flower power. Right. That line, if you're going to convert this radical into a fraction, it's really simple to do that because you know that this has got an index of 2. That's your root. 2. What's the power of this? I don't know. That's just the power of 1. Guess what? There's your fraction. So this could be written as log base 5, right, of 125 to the 1/2. Oh my goodness, that looks even worse, doesn't it? No, it doesn't. It's actually, you're almost finished. Because you know 5 to the power of v, 5 to the power of v now has to equal to 125 to the 1/2. And you know that 125 can be written as the power of 5. You know that from experience. This is 5v equals to 5 cubed. That's what 125 is 5 cubed to the power of 1/2. Wait a second. 3 times 1/2, isn't that just 3 over 2? Doesn't this become 5v equals to 5 to the 3 over 2? Cancel the 5's, v equals to 3 over 2. The answer, 3 over 2. That's simple. Straightforward. Even when I give you a radical like that, you can figure it out. It's easy, easy, easy. Look at this one. Here's another take of a really incredibly sweet question. You know that equals to v. Look how the pattern has always been the same every single time. Okay? 16 to the power of v equals to 1/2. Okay, first thing I'm going to do is I don't like that 1/2. So I'm going to change that to 2 to the negative 1. But how about 16? Well, we can convert that to a base of 2 as well. Then we have similar bases. Think about it. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's 2 to the power of 4. V equals 2 to the negative 1. Well, check this out. Cross a bracket, you multiply. So this is 2 to the 4v equals to 2 to the negative 1. The 2's cancel, leaving you with 4v equals to negative 1. Solve it. Divide by 4, divide by 4. V equals to negative 1/4. Oh my goodness. That makes all the sense in the world. Watch again now. Again, let that equal to v. 49 to the v. You'd probably be, at this point, already being able to figure this out. Right? Isn't 49 just 7 squared? Right? Look at that. Across the bracket, you multiply. So this is 7 to the 2v equals 7 to the 1. Cancel the 7's. You got 2v equals to 1. V equals to 1/2. Oh my goodness. Well, think of the relationship, though. Isn't the square root of 49 just give you 7? Doesn't a half exponent mean square root? Some things that you got to think about as you're going through this, eh? Well, let's look at this one. This is kind of neat, too, because, again, we're dealing with more radicals. Oh, man. Okay, so what? Relax. Let that equal to v. 2 to the v. 2 to the v equals to the square root of 1 over 1024. Now, I got an issue here. This 2 has to go into 1024. I don't know how many times, though. Well, wait. Before we do anything crazy, let's go one step at a time. One step at a time. Let's look at that 1024. Okay? I don't know what 2 to the power of what, but I know 2 to the power of 5 is 32. I'm going to start guessing big here. I'm going to go 2 to the power of 9. 512. Still, I'm close to 1024, but I'm not there yet. Okay, let's go 2 to the power of 10 now. There it is. There it is, 1024. Oh my gotcha. This becomes really, really easy. Watch how I'm going to do this now. Okay, so I know that that is 2 to the power of 10. But since it's over 1, watch what I'm going to do. Watch what I'm going to do. Isn't that 2 to the power of negative 10 then? Because isn't 2 to the negative 10 mean 1 over 2 to the 10, which means 1 over 1024? Yeah, no kidding. But now I'm going to square root this. Remember flower power. Remember it, because it's going to really save you when you're doing this. Okay? There's the exponent. That's the power. That's the name flower power. Okay? There's the square root. Oh, look how pretty this becomes. What's minus 10 over 2 going to actually be? Isn't that minus 5? Look at this. 2v then equals 2 to the minus 5. Cancel, cancel. v equals to minus 5. Look how pretty that works out. Isn't that wonderful? Yeah, it's actually really nice. Well, let's clean this up a little bit because I'm not going to have enough room to do anything else in here if I keep on writing things here. Okay, so let's put the answer here to be negative 5. Let's look at the next one. What if I do this? Huh? Uh-oh. What does that mean? Okay, don't worry about it. Look, this is 5 to the v has to equal to 5. Well, that's just too easy. 5's cancel out. V equals to 3. But wait a second. Isn't there like a way you can is there like a pattern or something here? Watch again. 7 to the v. 7 to the power of v equals, look what you have. 7 to the 1 point. Huh? Oh my goodness. So isn't there a pattern to look for? As a matter of fact, I already wrote it here. We just never referred to it. If this A and this match, your answer is just the exponent here. Now, is that anywhere on a formula sheet? No. But if you're ever stuck, you can always go back to this, go through it, and figure out that that's the answer. We'll do more in a bit.